We're now going to revisit something you did in lab. And when you did in lab, all we did was we did not have this term, right? We did not have that term right there. We said, no, we're pretending that there is, we didn't know about rotational energy yet. You didn't rotate any of that. So we pretended that wasn't there. Okay, so we're going to go back to something you did in your labs, where you roll a marble off a table. And you've got the kinetic energy of translation, which is just the 1/2 mv squared. So whatever velocity the marble is moving at, your energy in its linear motion is 1/2 mv squared. However, we have to now add in its rotational motion, because unless it's simply sliding along without rotating, it has rotational motion. And that rotational motion, the kinetic energy of that rotational motion, is 1/2 I omega squared. So now when we think about, we put a ball on a slope and we let it roll down and take off on a table, what is its motion now? Well, it's more complicated. The energy is more complicated because it's 1/2 mv squared plus 1/2 I omega squared. And how do you get to what I omega squared is? Well, you got to remember, omega is what? Omega is linear velocity over that radius. And if you look at a ball and you think about its rotation, the radius of the ball and the velocity it's moving along at are all you need. Omega is that velocity over that radius. I, for I of a ball, I of a marble, you just go back to the table several slides ago and you look at a solid sphere spinning around any diameter, 2/5 mr squared. And that gives you the moment of inertia for a sphere. So as we put all of that together, right, if we talk about this little lab we had you do where you rolled a marble down a piece of cardboard and off the table, mgh is 1/2 mv squared plus 1/2 I omega squared, where the h is the height that you had your marble at over the off the table, right? So it rolls down, it converts that potential into linear velocity and rotational velocity. And so the moment of inertia for the ball, 2/5 mr squared. Since omega is v over r, we can put it all together. mgh is this longer expression, right? mgh is this longer expression. And so it ends up being 1/2 mv squared plus 1/5 mv squared. So the velocity is not as high, right? Before, if you don't take into account the rotation, you end up with your velocity being the square root of 2gh. Well, now it ends up being the square root of 10 over 7 gh. Well, 10 over 7 is less than 2. So the velocity is not as high as it would be if linear motion were the only thing we had to consider. And that tucks away what we did in that lab a little bit better.